Hi, I'm Joseph Sabo, and in this video, I'll be reviewing a Java application I developed during my IT 145 Foundations and Application Development course. This was one of the first real projects I worked on in computer science, and it really helped me get a comfortable grasp on the basics of software design and object-oriented programming. I want to walk you through this project, how it's structured, what it was originally designed to do, and the enhancements I plan to make um, for this project. The goal of this program was to help a fictional company, Grazioso Salvar, manage rescue animals. These animals, um, specifically dogs and monkeys, are being trained for search and rescue missions. The application gives users a simple menu-based interface that lets them do a couple things: intake new animals into the system, the reserve animals for service, and print different lists of animals based on type or training status. This is a good example of a system, how to structure a small utility tool that supports basic operations like what you'd see in a internal system for animal shelter or training organization. This program uses a classic object-oriented design. At the core is a class called Rescue Animal. This one, this class holds common attributes shared by all of the rescue animals. Things like name, animal type, gender, age, weight, acquisition date, acquisition country, training status, whether they're reserved or not, and where they are in the country. So these attributes are shared attributes between all the animals, which there's only two right now. And then there's a dog class. And in the dog class, there's attributes that are specific to the dog, such as breed. As you can see, there's also all these variables that don't need to be in there. Um, so that's one of the enhancements I'm going to make because we can just clean this up because yeah, this class only needs dog specific attributes. And then you go in the monkey class and it's kind of the same thing. We can get rid of a lot of these. Um, but the monkey has its own specific attributes such as species and tail length and height and body length. That's specific to the monkeys. Then you just have your getters and setters down here. And then we go to the driver class that runs all the main logic. Basically, this handles user input using a scanner, stores dogs and monkeys in separate array lists, and contains methods to manage tasks like adding animals, reserving them, and printing out lists. I'm going to go through this driver class. You can see all the setting up these array lists for um, dogs, the monkeys, and the species. And then we come down here, set up the scanner, and we have switch for all these cases. These is going to be the menu options. Come down here, this is the display menu function. And these are just the options that the user will first see. So they can have the option to intake a new dog, intake a new monkey, reserve an animal, or print a list of all dogs, all monkeys, or all the animals that are not reserved and are available. And then, of course, an option to quit the application. Here, initializing dog list, I just put some dogs in here for some testing. We got initializing the species of monkeys. So these are the only species that are allowed to be entered in the system for the monkey. Then you have intake new dog function, and this just goes through the questions that will be asked to the user when they're intaking a new dog, getting the information like breed, dog's age, getting all that into the system. Up here, I did notice that it asked for the dog's name, and then scans the array list, and if the program finds the dog's name already in the system, it says this dog is already in our system. And I think that is a problem because it's pretty common to have um, two different dogs with the same name. I don't think that's uncommon, so that's something that we'll switch to, something that will change. There's just questions about the dogs, whether the dog is reserved, yes or no, and then validation for input. So if the user types anything other than yes or no, they will be asked again, invalid input, enter yes or no. Um, then we come down here and there's a bunch of questions for intaking a monkey as well. So the user will be asked, what is the monkey's name? Just kind of the same thing, except for specific questions to the monkey, such as what does the species belong to, the monkey's tail length, age, weight, and all of that. And then we have this function for reserving the animal. If you want to reserve an animal, just type in the information that it will pull to reserve. And then we have the print animals function down here. Choose three options, choosing to print a list of all the dogs, all the monkeys, or all the available animals. And then we're going to come up here. So as you can see, sorry about that. As you can see, there is already a lot of things I mentioned that I want to change or that I need to fix. But overall, I think the things that are really working well for this application is just the basic overall structure. I think using inheritance to separate shared and unique properties between animal types made the code cleaner and easier to manage. There's some stuff we can clean up, but once it is cleaned up, I think it's overall pretty good structure. It's a pretty simple structure. Um, Also, the menu system is intuitive, gives the users a simple way to interact with the program. Um, I noticed that there is a lot of validation that I could add in here when it asks questions about the dog's name, age, and all that stuff. You really can enter like anything you want. There's like nothing stopping you. So one enhancement I will make is when you're typed in the dog's name, make sure that the user doesn't put any numbers, and then when you're entering the dog's age, just make sure that the user is not entering any letters. So just all of that security stuff that might cause issues. And since the animals are just identified by their names, which isn't reliable, especially if they're duplicates, I'm gonna introduce a unique ID number for each animal to make it easier to identify them when updating or deleting records. And speaking of updating and deleting records, one thing I plan to do is add full CRUD functionality. So I think this system would benefit from adding functionalities to be able to update animals, um, update animal records, and then delete animal records and search for animals by name. So I think that would really help out this application. In order to do that, I think I'm going to create a database helper class. Right now, all the data is stored in memory using array lists, and that works for a small scale testing, but it's not realistic for real world use or scalability. So if we create the database helper class that manages a connection to a relational database, handling all the core database operations, which will help the program be more scalable and more efficient. To make the database interactions more secure and efficient, I'm going to use prepared statements. And That's important to use because it'll protect the application from SQL injection, and it'll ensure that all the inputs are properly escaped. It'll improve performance for repeated queries. And overall, I'm just going to plan to, you know, get rid of a lot of this stuff that we don't need, kind of refactor the code, do better comments, kind of clean it up a little bit. I think there's room for improvement managing the differences between dog and monkey data. Each animal type has its own unique fields. So um, I'm going to update the code and the database structure to make sure those fields are handled correctly. Right now, dog and monkey, they just kind of feel like they're jumbled up, and you don't want to get them confused as same object. So I think a little bit more separation will do this good. Performing the enhancements that I've been talking about will align with our core concepts in our curriculum by using an existing program to include or enhancing an existing program to include more robust features like search, update, delete. We'll be solving real world problems with algorithmic logic and structured design, refactoring the code to support modularity and scalability, introducing the database helper class and separating concerns, and making design decisions like using a relational database versus in-memory storage will showcase my ability to evaluate trade-offs. The use of prepared statements will demonstrate my security conscious and professional data handling practices, creating a database-backed architecture. Oh, excuse me. Creating a database-backed architecture architecture shows forward thinking for real-world applications, and building a more modular and maintainable structure aligns with industry expectations for software architecture. That will wrap this one up. I'm going to roll into my second artifact. This is my code review for my second artifact, which falls under the category 2, algorithms and data structures. I chose to enhance this project from my CS360 class, mobile architecture and programming course. I built a warehouse app on Android Studio that allows users to securely log in, manage items in inventory, including adding, deleting, editing, and updating item quantities, and opting into SMS notifications for low stock. First, I'm going to walk you through the app and how it works. Get it loaded up here. What you'll see first is title, inventory manager, the logo, and username and password. And on this screen, allows users to enter the username and password to log in or create account. So I'm just going to go ahead and log in using my previously filled out information. So the next page is your inventory page, which shows all your items, shows the item name, item quantity, and the item unit. On the left side, we have little pencils that are buttons you can click to edit the item on that line. And this trash can on the right side allows you to push that and delete the item. And then on the bottom, you can add a new item. So we will add an item. This is the edit page. It will ask you for the item name, the quantity, and unit of measurement. So we can type in um, something random. Let's do hammer 12, and each. Once you hit submit, hammer will show up on the inventory list. So instead of 12 hammers, let's say somebody took 2, so we can edit this. Instead of 12, we can move it to 10. save that, and it will move to 10. And then we can delete it, and it'll delete the whole row. So I went over that pretty quick, but that's basically the whole app. The only thing that you guys didn't see is the SMS permission activity, and that's because the app is designed for this page to pop up when you first log on, and only when you first log on. You can either accept or deny these permissions, which allows you the option of getting the SMS text when the stock hits 0. Let me get that. So that's just the screen that you would see typically the first time you log in. Actually, let's see if I can create a new account and get this to pop up. One second. And I'm going to try to enter a new username and password and see if I can get the SMS page to show. And it did not show up. So that is one thing I will fix during the enhancements. Okay, now I will go and talk about the code. We start by looking at the main activity, which is the entry point for the app. It sets up the screen for displaying inventory items in a recycler view. The main activity initializes a recycler view to display the list of inventory items. This recycler view is linked to the inventory item adapter, which handles the display logic. The activity also creates an instance of inventory database helper to fetch all the items from the database. The inventory data is then loaded into the inventory list, which is then passed to the adapter to display in the recycler view. Here's the SMS permissions. The app checks if it has permission to send SMS upon login, and if it doesn't, it will prompt the user for permission using the SMS permission activity page, which I showed earlier. And the app also manages whether or not the permission prompt has been shown using shared preferences. The inventory database helper class is responsible for managing all interactions with the SQLite database that stores the inventory data. The database consists of a single table called inventory with columns for item name, quantity, and unit. With CRUD operations, so we have add item, method add item, which inserts new inventory item into the database. The update item method modifies an existing item's name, quantity, or unit. And we have delete, which removes an item from the inventory using its name, quantity, and unit to identify it. Each item in the inventory is represented by the inventory item class. The inventory item class has three main properties: items name, quantity, and unit. We use standard getters and setters to retrieve or modify the properties of an inventory item, such as get item name, get quantity, or get unit. The add item activity is used when adding new item to the inventory. The user interface consists of edit text fields where the user inputs the item's name, quantity, and unit. When the user clicks the add new item button, the add item method is triggered. It validates the input and converts the quantity from string to integer. If the input is valid, the app adds the new item to the database using add item method from inventory database helper. After adding the item, the app returns back to main activity and refreshes the inventory list to reflect the newly added item. clears the old list, loads again to refresh the data, and tells the adapter to update the recycler view. The inventory item layout file defines how each inventory item is displayed in the recycler view. The layout uses a linear layout structure to display each inventory item's name, quantity, and unit. And like I said, there's a button on the right that will delete items and a button on the left which will edit items. Each text view is responsible for displaying the item's name, quantity, and unit. The activity data file is a layout for the main activity. It defines the overall screen structure, including the recycler view, um, which takes up most of the screen, displaying the inventory items, and the add new button that triggers the addition of a new item by launching the add item activity. This app provides a basic inventory management system where users can add, update, and delete and view inventory items. Also checks for low stock items and sends an SMS when needed, assuming the user grants the necessary permissions. But now I'm going to go ahead and talk about some enhancements that I am able to make for this. The enhancements I plan to make would be to improve its performance, scalability, and efficiency. First, I plan to replace the current list-based inventory system with a hash map. Using the hash map will allow me to perform faster lookups, updates, and deletions, since these operations are more efficient with constant time complexity in a hash map. Uh, this change would significantly reduce the need for repeatedly querying the SQLite database, which currently happens every time the inventory view is refreshed or updated. Second enhancement is to use batched updates instead of performing multiple database operations individually. For example, instead of opening and closing the database connection for each item added or updated, I will group changes together and apply them in one operation. This would reduce database overhead and make the app more scalable, especially with larger inventories than this one. Another enhancement would be to improve memory management by maintaining a single source of truth for the inventory, an in-memory structure like the hash map, which syncs with the database only when needed. This would help avoid inconsistencies and improve responsiveness, particularly in offline or low resource environments. These enhancements um, are technical upgrades and they also align directly with the course outcomes outlined in CS 499. I'll be demonstrating the ability to build and improve collaborative software environments by creating a more efficient and responsive inventory tracking system that could scale for warehouse teams. Um, Through this project and its code review, I'm practicing professional quality communication, both in writing and now in presenting technical information to an audience. The switch to hash maps and batched operations reflects the use of algorithmic principles and best practices for efficient computing solutions while managing the trade-offs of memory use versus database load. And I'll be applying innovative development strategies and optimization techniques to improve the performance of a real-world mobile application. But overall, this enhancement phase will be an opportunity to revisit a past project where I faced challenges and apply everything I've learned into improving both the technical quality and the user experience. It reflects growth not only in coding ability, but also in how I approach software design, efficiency, and maintainability. I'm going to continue this code review, jumping into my third artifact for category of 3 of databases. Okay, so for the third category of databases, I'm going to do a quick code review of a project that I built back in CS 340. It's an interactive dashboard for a fictional company called Grazioso Salvar. They specialize in training search and rescue dogs. The dashboard pulls data from the Austin Center and helps identify dogs that might be a good fit for search and rescue type of work. For this review, I'm focusing on the database side of things, how the app connects to MongoDB, how the data is handled, and what I plan to improve as I update this for my EAT portfolio. I picked this project because it let me work directly with real database integration, not just storing or reading data, but using it in a way that supports a working interactive app. The backend connects with CRUD module I built to interact with MongoDB. So it's all custom built to handle inserting, querying, updating, and deleting animal records. It really shows how I can tie together the backend logic with the front end interface that's easy to use and informative. So for the functionality of this application, we've got the logo here with the company, and this is all the animal data that's being pulled from the Austin Animal Center. And I added these buttons up here to fit the certain criteria that was asked for water rescue dogs, mountain wilderness rescue dogs, and disaster individual tracking dogs. So that pulls up all the info here. And then when you go back to all animals, it pulls up all the animals that are in the Austin Animal Center database. And down here, we got a single pie chart. And over here, we have this interactive map that will move locations off the animal that you choose. Click these animals, app or the map will move around. And it's kind of lagging, it's a little slow, but so I click on mountain wilderness rescue animals, and it shows all the dogs that would fit this specific criteria for that category. And they show up here. These are the breeds. And it's basically how it works. Numerically, the there's outcome, ID, type, breed, color, birth, date and time, month, year, outcome, subtype, contact, latitude, longitude, when they get out. So we have our dashboard file right here, and right here we have our CRUD module. And so right up top here, we have which is from the PyMongo library from Bison. Basically, Mongo client lets us talk to our MongoDB data is used if we ever need to reference MongoDB's UD IDs. We have the animal shelter class here. So the idea here is that we want to encapsulate all the functionality for creating, reading, updating, and deleting animal records from Mongo database collection. Then we have the method inside. Inside here, we set up database connection. Technically, it looks like the method accepts some parameters like username, password, and all that, but in reality, it's to use specific user and MongoDB Atlas URI. Right here, you say user, pass, host, and so on. The URI is MongoDB cluster. So if this were real, you'd replace this with your own credentials and for security. Then we use the Mongo client URI to connect, and we assign the database and collection we want to use. In this case, it's the database and the animal collection. Here we have the create method. So for this method, It takes animal data and insert it into MongoDB collection. It's pretty straightforward. And if the input data is empty or done, it'll throw an exception. Read method right here, which handles the R and correct. Like maybe you're looking for all dogs that are available, and it'll return a list of matching documents from the database. And if you don't provide a filter, it just returns everything in the collection, which is helpful for viewing the whole data set. Next, we have the update function. It's a filter to find the documents you want to change and the new data that you want to apply. It uses MongoDB's update many and applies the set operator, which means it only updates the fields you specify, which is very useful if you don't want to overwrite the whole document. And last, we have the delete function, which does exactly what it sounds like. If you give it a filter, like maybe you want to remove all animals who've already been adopted, and it'll remove them from the collection using delete many. Then it returns the number of documents deleted, so you'll know how many records were affected. That's the whole CRUD module right here. It gives you a solid foundation for interacting with MongoDB collection. Very useful for any app that needs a backend to store, retrieve, or manage structured data like a pet adoption portal, an inventory system, or even user profiles. I am going to be going over an example of using these operations, the create, read, update, and delete on a Mongo database using Python class called animal shelter. Um, Over here, this was loading pretty slowly, so I already have it typed out and I already got the results after running. So we start here, um, testing the animal shelter. I ran the username and password, so I'm just creating a made up, just made up animal data right here. So to first start out, we're gonna do the create module or the create method. And so we just created this dog right here for all this animal data, and it results in outputting document inserted. It's expected to be true, so down here you can see document inserted true. Next was testing the read functionality. Read data um, for the read the animal data for the name that matches Lassie. Copy. Next, we'll be going over last file, dashboard file here. So first, we import all the libraries we're using dash components like DCC and HTML, data visualization like Plotly, tables, and dash leaflet for maps. We also in a class from that other file, which handles our interactions with the MongoDB database, and we have the usual suspects like pandas, numpy, map, plotlib, plotting routines, and a few system utilities like OS. And here we set up the MongoDB connection with username and password, and then create a connection to the database through um, our animal shelter class. This lets us use the read and create methods to interact with the database. Instead of reading directly from the database for the first run, we load a CSV file that has all the shelter outcome data, convert it to a data frame, and then to a list of dictionaries. Each record gets inserted into MongoDB one at a time using our create method. As you can see, we even fetch some data back from MongoDB and print it to test that everything went in correctly. Printed the first 5 rows. It was just some debugging stuff that I put in here when I was creating this. Now moving on to into the dashboard itself, we're using Dash to build a web layout with uh, using down here we have down here we have 2 main display map section. These are updated dynamically when the user interacts with. Here's all the criteria for the wilderness rescue. Handles our buttons. And then here's our information. And here's these functions update our dashboard when something changes. The first callback updates the table whenever you a filter from the radio buttons. It fetches data from the Mongo on criteria like the breed, sex, and age. That was up here. The first callback was up here for all of that. And this would be the second that would generate a pie chart using plot currently visible data. It shows so you get a quick visual on which breeds are going to be the most common in your area. Next callback. This callback will highlight the cell of the data table when the user selects it. Just interactive, nice UX touch, user experience touch using conditional styling. And then next callback is the map. Callback to display the map with the selected animal's location. When a user selects a row in the table, this callback displays a map with a marker showing the animal's location, which was the hardest part of this code. I remember when I was working with it, it was definitely one of the more challenging things to complete. I did have to add this try to um, avoid any crashing if the latitude or longitude data was missing. Um, But yeah, that's our animal shelter dashboard. We've got data coming in from the MongoDB, and the user can interact with it through filters, charts, tables, and even a map. It's a full stack mini app all built in Python using Dash. So there's some good things about this code, use improvement. Some of the good things that MongoDB queries like and or, especially in the animal filters. Another thing that's going good is the CRUD module handles general and specific pretty smooth. I make sure to object IDs which avoids issues when passing data into Dash. Another thing is the filters work in real time. When a user selects the filter, the charts and map update instantly. That's to be able to do that. Uh, and there's some stuff that could use improvement as well. There are no indexes set up for fields like breed, sex upon outcome, and age upon outcome used in almost every filter. So indexing those would speed things up. There's also no error handling around the database operations. If something goes wrong with the query or a bad record gets application could crash. Is kind of repetitive. Each filter builds its own version of a similar query. So I think that cleaned up into one reusable function. So is it coded? Username and password are hard coded in script. So that's kind of what I'm doing, but definitely not something that you would want to have an app when you bring it into production for security reasons. And the last thing is, I believe this is uh, inserting all the data from the CSV file into the database every time the notebook runs. And I noticed that the data was getting pretty big if I ran it a couple times. So we need to fix that. Moving on to my planned enhancements. Uh, as far as the columns go in the database table, I want to add a couple more columns, including the intake date of the animal, which is not on here, and days in shelter. And I'm going to do that by generating realistic intake dates and then calculate how many days each animal spent in the shelter. Right now, we only have outcome dates, so we're missing that context. Adding this helps users understand shelter timelines better, like how long animals stay before adoption or transfer. That kind of insight can be really useful for decision making when they see that a certain breed or maybe older animals stay in the shelter longer. After those two columns, the next enhancement would be to add some more visualization charts that would give more data to the user. I want to add one graph that shows different types of outcomes like adoption, return to owner, and then another graph that breaks down how long animals stayed in the shelter, grouped by time ranges to see. I guess that info I think would be valuable for the people using this application. It would make it easier to spot trends or patterns and get what's happening in the shelter overall. Another enhancement I noticed that turns all animals in a shelter, and a specific app is for dogs. And so I think we should move this button, we call it dogs, and then just make um, dogs in the table. So now cats, birds, and all type of animals in here. As you can see, oh, this thing is not. There was yeah, animals in here. If there was just dogs in the table, that would make no sense. So changing the animal button to all dogs. So the dashboard would be more focused and useful. And the next enhancement I would make to refactor the logic to the single input. Um, queries were kind of repetitive, and so I think if I created something like get function, it'll make the code cleaner, easier to maintain, and especially if the filtering rules change, easier to maintain.